Good afternoon, everyone, and welcome to Stanislaus State's Science Week. My name is Sanpreet Kaur.
And I'm Chelsea. We are part of the Science Center community team here at Stan State.
Stanislaus State is pleased to provide the community with opportunities to learn by engaging in live activities and recorded activities that will be shared this week through Zoom and on Science Center Community YouTube channel.
Before we start, please note that this event is recorded and we'd like to ask for you to stay muted unless you're called upon. And additionally, to keep this activity fun for everyone, please use the chat to answer or ask questions. Thank you.
Now it is my pleasure to introduce our activity, Chemistry Goes Pop, with Chemistry Warrior Club and Dr. Aliman, Dr. Shahara, and Dr. Manchanda.
All right, hello everyone. All right, so we'll go ahead and get started. I'm gonna quickly share my screen. So hello once again. My name is Moises Nunez. I am the president of the Words Chemistry Club here at Stanislaus State. And as many of you guys already know, today's activity is on pop rock. How many of you guys like pop rock? Okay. Oh, I like them too as well. So we'll get started. So how does this experiment work? So pop rocks are sugar candies, and some of you may know or may not know, they have carbon dioxide gas trapped inside. So because of the carbon dioxide gas that's inside of them, when the sugar dissolves around the carbon dioxide gas, it's released and it creates a popping sound. So that's usually what happens. As you guys can see, the girl on the right, she has pop rocks, and the warm melt and the saliva are causing them to pop and releasing that carbon dioxide gas. So sugar can be broken down in various solutions, and such as water. So today we'll be using hot tap water and also cold water. If you don't have hot tap water, we can also use room temperature water, and the experiment should still work. So which one do you think will dissolve the fastest or create a faster reaction between the hot and the cold? And then aside from seeing which one is going to dissolve the fastest and create the fastest reaction, I would also like you guys to describe what you see, you hear, and what you smell during the process. So the materials that you'll need if you're going to be working on the reaction with us, you'll need about 2 packs of pop rocks. 1 pack will work. You can just split it in half. You'll need about 4 dry cups or bowls of the similar size. So these plastic cups are the ones that we're going to be using. They're about just 8 ounces, so just 1 cup. And then 2 half-cup measuring cups. If you don't have measuring cups or spoons or of any sort, for example, this is 9 ounces, and half of cup is going to be half of this, so 4 ounces works, and 120 milliliters will also work. And then, like I said, we'll be using cold and hot tap water, and her room temperature also works. And we'll be using spoons so we can stir our pop rocks into the water as well. So now that we gave a little brief introduction on what we're going to be doing, we're going to split into breakout rooms. And I hope you guys enjoy the experiment today. Okay, I believe we're in our breakout room here. Can everyone hear me fine? Yeah? Okay, well, I'm very excited to be here today. I honestly would wish to have you guys here in person. You know, it'd be a lot better leading out these experiments, but due to COVID, you know, we want to make sure our safety is first. So we're the Words Chemistry Club again. This is our logo. But anyways, we'll get started with our experiment today. So first things first, what we want to do is we want to label our cold water on one side. So you can just simply put a C on there so you can know. And then you want to label your hot water on one, so you can put an H. That'll work, or you can spell it out however you prefer. So we're gonna have that first. And we're gonna take 1 packet of Pop Rocks, right? And if you guys are working along with me, just follow along. Or if you guys are just observing, that works well. That works as well. So we have our Pop Rock. I'm gonna use the blue raspberry flavor. So I'm gonna split up half of it into one of the cups and the other half into the other. It doesn't have to be exact, but try to make it as close as possible. That should be about half. You guys can see the Pop Rocks right here. This is gonna be for the hot water, and the rest of the half is gonna go into the cold water. This should be about it. I'm gonna add a little bit more into the hot water one. And I think we should be even. Okay, that's about it. So here's our Pop Rocks. They're split into half, about maybe a little uneven on one side. So I'm gonna go ahead and add a little bit more. But I think we should be good now. All right, so now that we have our Pop Rocks split up, I already poured out my cold water onto one cup right here. Oh, if they want to use the whole packet, they could use the whole packet on one of them. It's fine. That totally works. Or they can just split up that one packet into 2. So whatever works. So I have an extra packet over here. If you guys want to split up, or if you want to use one packet for 1 cup and the other packet for a different one, that also works. So sorry for not clarifying that earlier. Anyways, getting back on track. So we're gonna get our cold water. So I already poured mine out, and since this is like an 8-ounce plastic cup, we just pour about half of it. Oh, okay. Sorry about that. Yes, I'll definitely slow down. Yeah, you guys just let me know, like, if I'm, doing this too fast or talking too fast. Feel free to let me know. I tend to do that sometimes, So I apologize. But let me know when you guys are ready. So I'll continue, and then like I said, if you guys would like me to slow down, just let me know. Give me a heads up, and we'll continue on. So once you label your cups and you pour out your Pop Rocks into your both little plastic cups here, you're gonna get your cold water on one cup. Make sure you know which one it is. If you need to label it as well, feel free to label it, just because you can get lost in the process, and sometimes you can't really tell between the hot and the cold unless you touch them. So feel free to label them as well. So I have my cold water here, and I'm just gonna walk down this little aisle here and get my hot tap water. So I'll be right back with you guys. All right, so I'm back. We have our Pop Rocks right here, and now we have our cold water on one side, and we have our hot water on this side. Okay, so now what we're gonna try to do is we're gonna pour both of our cold and the hot water into the corresponding cups right here. Okay, so you want to pour them in at the same time so you can see the speed of the reaction, like how fast it happens, or see which one pops a lot faster than the other. So that's pretty much the whole idea of this experiment. So I'm gonna go ahead and pour them, and I'm gonna show you guys what's gonna happen. Okay. Woo. Okay, so one of them, the hot one, started sizzling right away. So be careful with that one. Okay. Okay, so be careful with the hot one if you have hot water. If not, stick to room temperature, because it could cause some of the Pop Rocks to just bounce off. And as you can see, you can hear the little crackling going on. For those of you listening in, you can hear the little crackling or the popping going on. And then you can feel free to also use your spoon and swirl it, and then see which one is dissolving a lot faster than the other. So for me, I can tell you already that the hot water one won by a mile. It's already dissolved, the hot water one's on the right hand side over here, and the cold one is on the left hand side. You can still see some of the pop rocks dissolving. So whoever selected the hot tap water, give you guys a pat in the back because you guys got the right answer. So now you guys are probably wondering why it is that the hot water sped up the reaction a lot faster or dissolved them. So the simple explanation for this is that when you have hot water or just any hot solution added to a reaction, it causes the molecules. So for example, in this case, it would be the pop rock molecules. It causes them to move at a very, very faster rate. So because it's moving at a lot of faster rate, it tends to dissolve a lot faster. And that's the reason why it caused for them to fully dissolve within like about 10 or 20 seconds. And then versus the cold water still hasn't fully dissolved. There's still some particles in there as well. So that's pretty much the general explanation there. So in chemistry, we also use temperature to speed up our reactions. It's a form of increasing the reaction rate. But it's a pretty simple experiment. You can do this at home. You can try it with your siblings, with your parents, and you can observe what a temperature does or how it affects the reaction. Okay, so yeah, once you guys are finished up with that, with your experiment, and you kind of just analyze what occurred. I still have mine here going. Pretty nice color actually. I really love this color, turquoise. But anyways, once you guys are finished up, you guys can also complete your observation section. And this is similar to what we do in a chemistry lab or just in labs in general. And the observations you can talk about is describe what you saw, what you heard, or what you smelled during the experiment. That way, you guys are on the right track to one day maybe become great chemists. So yeah, just feel free to do that when you guys are finished up with your experiments. Describe those 3 things. And then if you guys have any other questions, like I said, feel free to drop them down in the chat and let me know if you would like me to clarify something. So just to talk a little bit about myself, and the reason why I chose to do chemistry is because we get to do a lot of fun reactions like these, and it's just a great experience overall. You learn a lot. You'll learn a lot in your lab. If you do research, you can get paired up with one of your professors. You can get paired up with them, and you can learn a lot more about reactions or about how chemistry works. And there's just a lot of fun things that you can learn, and you can hopefully apply for your career in the future. And yeah, it's been a great experience, and I hope that maybe one day one of you guys will decide to go into chemistry here at Stanislaus State or at any other institution. So I hope you guys enjoyed the experiment. I think we're going to be closing up our breakout rooms pretty soon. Yeah, it was nice seeing all of you.
Thank you everyone for joining us for this activity. Science Week would not be possible without the dedicated students, faculty, and staff here at Stan State.
Thank you so much for watching. Please follow us on social media to find more about our upcoming events.